All right, day 2, properties of logarithms. So yesterday we talked about the product and quotient property. And today we are going to talk about the power property and then how to evaluate logarithms that you cannot necessarily rewrite as an exponent. So we will start with the power property to kind of relate it back to exponents. So when we are raising an exponent to a power, we multiply. Now this one is a little bit harder to kind of see as opposed to the product and quotient. I think those are a little bit easier to kind of visualize. So what the power property will look like for logarithms is that if we have log base b, and whatever we are taking our log of, we are raising to a power. So kind of like we are here. So we're raising that to a power. Well, when we evaluated it, we multiplied together. So what we're going to multiply is our exponent by our log. So what I kind of like to think of, instead of honestly necessarily even the related exponent property, just because it's a little bit harder to see, is whenever you've got your exponent, you bring it out in front of your log and then you multiply it by that log. So that would look like n times log base b of m. And so that is the multiplying part, like this right here. And it's just a little bit harder to see. All right, and so now we're going to talk about the change of base formula. So on Friday, every logarithm that we evaluated, we could rewrite as an exponent. So what I mean by that is we looked at something, for example, like log base 5 of 125. And we could evaluate that without a calculator because we could think of that as 5 to what power equals 125, and we could easily come up with 3. Okay. And then we talked about how you can also evaluate anything that's in base 10 on your calculator because that is the true base of the common log. So for example, if we just had like the log of 20, even though we can't rewrite 10 to a power as 20, we could just type that into our calculator, right? Remember the log button is right here. Because this is base 10, you can just type that in and evaluate it that way. So that means 10 to about the 1.3 power is 20. 10, okay, 19.95. Okay, so it's pretty close. Well, what if I changed that base? What if I said log base 4 of 20? Now we cannot type that into our calculator, okay? Because that is not base 10, and that is the base of the common log on your calculator. So these really old mathematicians kind of figured out just by playing around in base 10 was that they found that if you take the ratio of the log base 10 of whatever you're taking the log of and the log base 10 of your base, that is how you can simplify this without necessarily guessing and checking. Because we could still think of this as 4 to what power is 20, and then just kind of do trial and error on our calculator until we get as close as we possibly can. But we want a more efficient way to do that, right? So that's where this change of base formula comes in. I probably should put that down in the example, but this will work every single time. And so now what we just have to evaluate, now that I've changed my base to 10, now I can just type in the log of 20 divided by the log of 4, and I get my answer. So that's about 2.161. We're going to be rounding to the thousandths here. So if I think about that as 4 to what power is 20, when I evaluate this, 2.4 to the 2.161, I should get something pretty close to 20. I'd say that's pretty close. Okay, and so that's the change of base formula. If we write it with variables, it looks like this. Log base, that's with B, since that's what we've been using. log base b of m is always the ratio of log base 10 of m over log base 10 of b. So if we want to do another quick example, if I had log base 5 of 30, okay, that's going to be the ratio of log base 10 of 30 over log base 10 of 5. Okay. So when I type that in my calculator, now that I'm in base 10, I can do log of 30 divided by log of 5, and I get about 2.113. So if I can look at this log and think, okay, that's 5 to what power is 30, and I can check my answer, 5 to the 2.113 power, I should get something that's pretty close to 30. Again, they're not going to be exact because I'm rounding all my answers, but it should be within 10, so 0.999 or 0.000, something like that. Okay, so we're going to kind of look at similar examples to what we did yesterday using these two properties while also incorporating some of the properties from yesterday as well. Okay, so whenever you see now a power, so yesterday we kind of started, do you see multiplying or dividing? Now we're going to add powers to that list. Okay, and now we can always work backwards. You always start by kind of like moving your, well, never mind. We'll talk about that as we get to an example. I don't want to bombard you guys with too much information at once. So for example, in this one, I've got the natural log of x plus or x to the 6th power. Since this x is not being multiplied by anything, I don't have to worry about taking apart multiplying or dividing. So now I'm just going to move my power out front. So that 6 is going to go out front, and it's just going to be 6 times the natural log of x. There's nothing else we can do to simplify. In this one, I've got the natural log of e to the 6x. So this e, that's the base of the exponent. That's not being multiplied or divided by anything. So this whole thing is my power, the 6x. So I'm just going to bring that out front, and that's now going to be 6x times the natural log of e. Now we have to ask ourselves, can I simplify that, right? Well, here, the base of the natural log is e. That's e. So remember, these cancel each other out. E to what power is e? That's 1. So this is actually just going to be 6x. If you remember that inverse property from Friday 2, we could have taken care of that right away, because when the base of the log and the base of the exponent are the same, that's going to leave you just with that 6x. Okay, so now you can use properties of logs to evaluate that as well. Okay. All right, so now here I see kind of something a little bit different. I see some dividing and some powers. So we always take apart the multiplying and dividing first, unless you're raising that whole product to a power, which I may add an example of just to kind of show you what I'm talking about here. So the first thing we're going to do is separate the numerator and denominator through the quotient property. So log base 3 of x to the 4th minus log base 3 of y to the 3rd. Okay. And so from here now, I'm going to bring my exponents out front. The x and the y are not being multiplied by anything, so I don't have to take apart any multiplication. So now that's just going to be 4 times log base 3 of x minus 3 times log base 3 of y. And that would be my final answer. Okay. All right, so now in this last one, I see I've got the 4th root of y squared. So we have to kind of think back to our special cases when we were solving about how I transfer back between radicals and exponents. So we have to remember that the 4th root of something is the same as the power of 1/4. So I can change this to the natural log of y squared raised to the 1/4 power. And then instead of bringing an exponent out twice, we can simplify this first by using this direct property, because right now we're kind of focusing on simplifying what I'm taking the log of as much as I can. So 2 times 1/4 is going to be 1/2. So the natural log of y to the 1/2. Y is not being multiplied or divided by anything, so I don't have to take that apart. So now I can just bring that 1/2 out front. So 1/2 times the natural log of y. Okay, so what I mean really quickly, maybe I'll add example E over here. What I mean by like taking apart multiplication before bringing powers, because most people have no trouble with the division, doing that first. But if I were to give you something like this, like log of 2x to the 5th or something like that, a lot of people's eyes go to that exponent first and bring the exponent out front. But only the x is being raised to that power. The 2 is not. So before you can bring the exponent out front, you have to make sure you split apart the multiplication first, just like we split apart the division first here before bringing the exponents out front. So you'd have to break this up first into the log of 2 plus the log of x to the 5th. Now you can take that exponent out front. So log of 2 plus 5 times the log of x. Okay, if I put parentheses around that, then I'd be able to bring the 5 out first, and then I'd separate the multiplication. So it all just kind of depends on what your power is attached to. Okay. All right, so now we're going to condense a couple, and then we're going to practice that change of base, because that's how we're going to solve the majority of the equations that we're going to look at in the rest of this unit here. All right, so we're going to use properties of logarithms to condense the expression. So now when I'm going backwards, remember I'm looking for subtraction, I'm looking for addition, and now I'm also looking for any number that I'm multiplying my log by. So I see this right here. So now I'm going to work in reverse. I'm going to put my powers back where they belong. So if that 2's out front, that means it started as an exponent here. So this is going to be log base 5 of 4 minus log base 5, and then 5 squared is 25. Okay. Remember, I'm trying to condense this to a single log, and so I don't want to simplify that. I want to put it back together with this. And so now when I see that subtraction, I put that back together by dividing. So log base 5 of 4 over 25. Okay. We'll practice changing the base on the back. I just want to focus on these first. But then what we could do from here if we wanted to evaluate it further. So this specifically says just to condense it. So I would just kind of want it like this. But if I asked you to evaluate it, then we would do the change of base and put that in our calculator. But right now we're just condensing it to a single log. All right, so now here we've got kind of our 3-stepper. So we're going to work from left to right. Now we're going to start by looking to see if anything is being multiplied by our log. Start by putting that back into the exponent. Okay. And then there's nothing in front of that one. So this is going to become the log of 36 minus the log, and 3 to the 4th is 81, minus the log of 3x. Okay, so I'm going to start, this is all going to be division. So this divided by this, and then whatever that is divided by this. Okay, so we may get a little bit, there's going to be a lot of fractions involved here since we're kind of dividing several times. So I'm going to start by doing 36 divided by 81, and I get this. Okay, so remember to change that decimal because we need these to be exact. in order to change that into a fraction on this calculator above the probability key, there's this little F with an arrow pointing to the D. So we need to get there. So you always hit the second key and then that, and we get 4/9. Or you can simplify it by hand, right? 36 over 41 or 81 and simplify it that way. So now I have the log of 4/9 minus the log of 3x, and we're going to be dividing here. So I'm actually going to work this out kind of the old-fashioned way so that we can also review some fraction properties. So if I'm taking 4/9 divided by 3x, and that's really over 1, 3x over 1. When we divide fractions, we multiply by the reciprocal. So this is really 4/9 times 1 over 3x. And now when we multiply fractions, you multiply straight across the top and straight across the bottom. So that's going to make my final answer here the log of 4 over 27x. Okay. And that would be my final answer here. All right, so now on the back, we're just going to practice really just typing in change of base and using the power property on some of these. So is that the same example I gave on the front? Sure is. I must have looked at that and subconsciously did it. All right, so we already did this example here. So really, remember, we need to be able to visualize the log as an exponent. So this is really 4 to what power is 20? Since that's not going to be an exact answer, I'm going to need to use the change of base, which is the ratio of the log of whatever you're taking the log of 20 over log base 10 of your base. Now we've changed into base 10. We can evaluate this on our calculator. So log of 20 divided by log of 4 is 2.161. Again, you can check your answer. If you can visualize that as an exponent, you should be able to type in 4 to the 2.161 power and get something pretty close to 20. So this is kind of the same. This is really 4 to what power is 10. Well, I can't evaluate that with a whole number or a negative or a fraction or something like that. So we're going to have to use the change of base. So that's going to be the log of 10, the ratio of the log of 10 divided by the log of 4. Okay, so the base is always, the log of your base is always what goes in the denominator. So then when I type that in, now that I'm in base 10, it's going to be the log of 10 divided by the log of 4. So that's going to be about 1.661. Again, you can check that too because I evaluated for that exponent essentially, so I should get something pretty close to 10. All right, in this one though, I see this 2 out front first. So before I can do the change of base, I want to put that back. So that's going to become my exponent. So that's really log base 6 of 25. And so now I can't do 6 to a power and get 25. So I'm going to take the ratio of the log of 25 divided by the log of 6. And I get about 1.796. And so now I can kind of check that because again, I'm solving for my exponent. 6 to what power is 25? So 6 to the 1.796 power should get me pretty close to 25. It's 24.978. In this one, I'm going to start by moving my power up here. So 81 to the 1/2 power is the same as the square root of 81. Okay. So that's going to be 9. Now here, if you can visualize this as an exponent, now I don't have to use the change of base because this is really 3 to what power is 9. So this one's actually nice because that's just going to be 2. Okay. All right, let's change this to 100 just so it's not the same problem. I didn't realize that was the same problem as number 2. So log base 4 of 100 is 4 to what power equals 100. Well, there's not an exact answer for that. So I'm going to take the ratio of the log of 100 divided by the log of 4. Now that I'm in base 10, I can evaluate that. And I'm going to get about 3.322. And so we can check that by doing 4 to the 3.322 power. We should get pretty close to 100, which we do. Okay. So we'll see this change of base utilized a lot more when we are actually solving our equations. So your homework tonight is another just kind of set of practice problems, and then you'll take a picture and submit that assignment when you are done. Tomorrow you will have a review assignment over 7-4 and then the 2 days of 7-5 that we covered, and then you'll have a quiz on Friday.